Good morning. This is Sachin Biske from Electrical Engineering Department, SND College of Engineering and Research Center. In the previous lecture, we discussed related to the SCADA system or what this SCADA do for us and where this SCADA can be used. Today, we are discussing the data presentation. Before going to data presentation, all should have the knowledge regarding the data acquisition system. Firstly, the system you need to monitor are much more complex than just one machine with one output. So, a real life SCADA system needs to monitor the hundreds of the thousands of sensors, and some sensor measure the input into the system. For example, water flowing into a reservoir, and some sensor measure the output like the wall pressure as water is released from the reservoir. Some of those sensors measure the simple event that can be detected by a straightforward on-off switch called as a discrete input. For example, in our simple model of the widget fabricators, the switch that turns on the light would be a discrete input. In real life, the discrete input are used to measure the simple state like whether equipment is on or off or tripwire alarm like a powerful failure at a critical facility. Some sensor measures the more complex situation where exact measurement is important. These are the analog sensor which can detect a continuously change in the analog voltage or current input. The analog sensors are used to track the fluid level in tank, voltage level in batteries, and temperature and other factors that can be measured in a continuous range of input. For most analog factors, this is the normal range defined by the bottom and top level. For example, you may want temperature in the server room to stay between 60 to 85 degree Fahrenheit. If the temperature goes above or below this range, it will trigger a threshold alarm. In more advanced systems, there are four threshold alarms for analog sensor, defining major under, under, minor over, and major over alarm. Then we are moving towards the data presentation. The only display element in our model's SCADA system is the light that comes on when the switch is activated. This obviously won't do on a large scale. You can't track a light board of 1,000 separate lights, and you don't want to pay someone simply to watch a light board either. A real SCADA system reports to human operator or a specified computer that is variably called a master station, an HMI or an SCI. The SCADA master station has several different functions. The master communication monitors all the sensors and alert the operator when there is an alarm. That is when the control factor is operating outside what is defined as its normal operation. The master presents a comprehensive view of the entire managed system and presents more detail in response to user requests. The masters also perform that data processing on the information gathered from the sensor. It maintains the report logs and summarizes the historical trends. An advanced SCADA master can add a great deal of intelligence and automation to our system management, making our job much easier. Then it has some control. Unfortunately, our miniature SCADA system monitors the widget fabricator doesn't include any control element. So let's add one, and let's say the human operator also has a button on his control panel. When he presses the button, it activates a switch on the widget fabricator that brings more widget parts into the fabricator. Now, let's add the full computerized control of a SCADA master unit that controls the entire factory. You now have a control system that responds to input elsewhere in the system. If the machine that makes the widget part break down, you can slow down or stop the widget fabricator. If the part fabricator are running efficiently, you can speed up the widget fabricator. If you have a sufficiently sophisticated master unit, these controls can run completely automatically without the need of human interventions. Of course, you can still override the automatic control from the master station. In a real life, the SCADA system automatically regulates all kinds of the industrial process. For example, if too much pressure is building up in a gas pipeline, the SCADA system can automatically open a release valve. Electricity production can be adjusted to meet the demands on the power grid. Even these real world examples are simplified. A full-scale SCADA system can adjust and manage the system in response to multiple inputs. Thank you.